So chapter 2 is going to feel very familiar. The first section, if you look here, is just on the rectangular coordinate system and graphs, and that's what we're going to look at today. And they're very, it's going to start out very simple and straightforward. As you go through, if you look, each section, it kind of builds upon the last one, and so 2.1 is probably the easiest, the most familiar, and then 2.7 you'll still have done at one point in algebra, but it's just a little bit more. Okay. So today in 2.1 we're going to talk about plotting things on the coordinate plane, graphing equations. We'll talk about Desmos a little bit. So if you are a person that hasn't got Desmos out of self-service, I would suggest getting your Desmos ready. We're going to talk about intercepts, the distance formulas, and the midpoint formulas. Most of this section is going to be a review from Algebra 2. So let me remind you some things about your Cartesian plane. The Cartesian plane was named after a mathematician named Descartes. He was a French mathematician, and it's just we are showing our two coordinate planes, our x-axis and our y-axis. Remember that the quadrants start here. That's our first quadrant, and then it goes around counterclockwise. So that's quadrant 1, and then it goes to quadrant 2, and then it goes to quadrant 3, and then it goes to quadrant 4. Most of the time you're going to see those Roman numerals. So if you see, I'll probably write quad 1, quad 2, quad 3, and quad 4. Especially in the second semester, when we go to do some trigonometry, knowing where the quadrants are and whether they're positive, negative, all that stuff is very helpful. So let me remind you that any point in quadrant 1 will be positive. Any point in quadrant 2 will be negative, positive. Any point in quadrant 3 will be negative. And all the points down in quadrant 4, since we're going to the right and then down, are positive, negative. So remember, starts here and goes counterclockwise. So that's pretty straightforward. You should remember that, I would assume. Now, let's just take a minute. Let's plot some things just quickly so that we remember how to do that. Again, this is very much review, this section. You'll like this section. It'll be quick and easy, I think. So if you have a point, remember that your x comes first and then your y is just, standard, good old alphabetical order. The x always goes left to right, and the y always goes up or down. For the x, if we are going in the negative direction, we are going to go left. So negative 2, 4 takes us in the second quadrant because we're going to go left and then we're going to go up. So negative 2, 4 goes to the left and up 4. Now, if they gave those a name, if they used, say, a capital letter, make sure you place the capital letter next to it. If they gave it a lowercase, give it a lowercase next to it. And then 3, 3, positive. So you're going to go 3 to the right and up 3. And then 0, negative 3, that is considered a quadrantal. It's called a quadrantal point. If we land on one of the separations between the quadrants, either the x or y axis, we consider that a quadrantal point. So 0, negative 3 means I go left and right nothing. I just go down 3. So that's our negative. So we're going to go down. I will try to provide you graph paper when necessary. Again, keeping a picture of graph paper in your photos is probably just a really quick way to always have access to it. Remember, when you're dealing with notability, the 3 dots in the corner, see where it says templates there. If you go to templates, you do have the option for the basic templates to get lines, dots, or a grid. So you can change your paper or add a sheet that has graph paper on it too. Okay. So now let's talk about graphing. Now in this class, my goal is for you to graph quicker maybe than you did in Algebra 2. So not very often I'm going to have you graph something by plotting points, or if I do have you graph something by plotting points, usually 2 to 3 points is going to get you what you want. Many times, because of the more complex graphs we might be doing, 3 points might be good. This is a linear graph. How do we know that? If your x and your y are both to the first power, if it is either in the form, so a linear graph is either of the form ax plus by equals c. That's your standard form of a linear equation. Y equals mx plus b is a common form that this one is in. There's lots of ways to graph it. This is not the most efficient way when they say to plot points. But for a linear equation, this happens to be just a line. And for a linear equation, you only need 2 points to plot it correctly. It doesn't matter which points you pick. It is helpful to pick something that's going to get your point in a nice place. Let's just, it tells us to plot points, so let's just plug in -1, 0, and positive. Sometimes that's very helpful. And I'll try to start eventually when we get more complex graphs to talk about how we go ahead and can really pinpoint the best points to plug in if we're going to do it like that. Now, to plug in something into this, remember you have to follow your order of operations. So if we plug in -1, make sure to use parentheses, 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 just to make sure that negative flips correctly. So in this particular case, your 2 negatives are going to make a positive. So that's going to be a +1. So that's going to be a 3. If we plug in 0, we get y equals the opposite of 0 plus 2, which is still just 2. And then finally, if we plug in 1, we get the opposite of 1 plus 2, which is 1. You should see, since it's a linear equation, you should see usually a pattern of some sort, especially if we've done -1, 0, and 1 like this. You'll see it has that very nice 3, 2, 1 pattern. So let's go over to -1 and on the x-axis and go up 3 for our first point. 0 goes 2, and 1 goes 1. And then really don't just connect those 3 points, really stretch your graph across your graph paper, because especially when we go to maybe do a system or do a few different graphs all at once, it's helpful to really have that graph stretched across your graph paper. Yes?
How do you make it a straight line again?
So on Notability, I'll kind of do it to the side. If you want to make a straight line, try to be accurate, especially on your starting point. And then as you go down, if you just hold it, and then you do have control over this bottom piece as far as where you land it, and then release. And that will make you a straight line. So it's more important, because you don't really have as much control on the top point. Make sure you get the top point in the spot you want, and then as you drag it down and then hold it, it will let you kind of move it precisely where you want it on the end. So there is a linear equation. Let's just talk real quickly about some things about this line. If you look at it in the realm of the y equals mx plus b, our y-intercept is the b. That's this point right here at 2. It hits the y-axis at 2. Our slope is -1. We go down 1 over 1, down 1 over 1. Rise over run is -1. We see it's going downward from left to right. So it's a really clear indication that what we graphed is what we wanted to graph. And we will discuss slope and intercepts and all that stuff as we go. Here it says to use a graphing utility in Desmos. So for those of you, if you've already put Desmos in, that's the little green. It has a parabola and a sine wave on it. And so if you were to type this into Desmos, if it's explicitly solved for y, so if it says y equals all the other junk, you can just type in that other stuff. So you can, if it says y equals, can you type in negative 2/3? Now, what you'll see, I have my fraction typed in. I need to get out of the fractions denominator, so if you pop the right arrow over, you'll get over where you can type in x. And then when you do the 4/3, just use the division bar to make the bottom of the fraction. And there's our graph, okay? Now, if you're unsure, then just put the y in. So you'll notice, let me kind of hide that for a minute. If we type in exactly what's on the screen, or for the equation, negative 2/3 y equals negative 2/3 x minus 4/3, we get the exact same equation. You see how they just are lined up on one another. They're the same exact thing. So as we go through it, our equations are going to become more complicated, and you probably want to put the whole equation in. But for linear equations, or if it says y equals, you only really need that back portion. So let's put our graph, now that we've looked at it on Desmos, let's put it on our chart. Just so that we have some points that are nice. One point on this graph that's pretty nice is 1. If we plug in 1, we get negative 2. So over at 1, we're down 2. And you can see our Desmos here at the point. Did I type it in here? And did I do my math right? Negative 6/3 is negative 2. Okay, so at 1. Yeah, I am right. Okay, I'm sorry. I'll scroll and stop there. Yeah, there we go. See, a 1 is at negative 2, so that's a good point. See, this point isn't as nice. That's the y-intercept is negative 4/3. If you want to always guesstimate where those decimals are, feel free to. But see, this point's nice. So negative 2, 0. So you can take any points off of Desmos. If you just tap on those, you can find those points. So let's plug in the point negative 2, 0. And again, let's try to make our graph kind of nice here. And there you go. Okay, so at Desmos, for a linear graph at least, you can find any 2 points along the graph and go ahead and connect them, and you're going to have a nice graph for yourself. So there's an example there. I think using Desmos is just a nice tool to help you get yourself, you can verify that what you have done is correct. You can, use it as a guide always. Now let's talk about the intercepts. That's an important concept we will apply not only to our linear equations, but we'll apply to other equations. To find the x-intercept, you're going to set y equal to 0 and then solve for x. To find the y-intercept, you're going to set the x equal to 0. I tend to call it my 0, 0 chart. If they say to find, the intercepts, so here you just let y equal 0. Here you let x equal 0, and then you have them. So that little 0, 0 chart is really helpful when finding your x and y intercepts. It's really a nice technique to use if your equation is in standard form, that ax plus by equals c. It's the quickest to graph and to find those intercepts. So let's go ahead and fill in our 0, 0 chart for this particular one. Remember, this is going to be our x-intercept, and this one is going to be our y-intercept. So we've got this equation, y equals negative 3x minus 4. Let's make y 0 and do the more difficult one. Usually the x-intercept is going to be a little more complicated mathematically, not much, but that's the one that's a little weirder. So we're going to let the y equal 0, and we're going to solve it for x. So just remember your rules of equations and solving equations. So when we move that 4 to the other side, it was subtracting on the right. We're going to add 4 to the other side. And then we need to divide off the negative 3 since it's multiplying, do the opposite. And so when we divide by negative 3, we get 4 over negative 3. So our y-intercept is negative 4/3. Oh, I'm sorry, our x-intercept is negative 4/3. So that means we hit the x-axis at approximately negative 1.3. When you get a decimal value for either of them and you go to graph it, just guesstimate as close as you think you can, eyeball it. And that's the problem with us graphing. We are never going to be as accurate as like the Desmos will be. Now let's do the other one. This time we're going to let x equal 0, and usually that's a little less complicated algebraically. Usually it's just kind of set up for you. Negative 3 times 0 comes first. We do that. Using our rules of algebra, we're going to get 0 minus 4 or negative 4. So not only do we find the x and y intercepts, but by finding 2 points, we are able then to graph our line very effectively. So if we go to negative 4/3 on our x-axis, negative 1.3, just guesstimate for me. Do as close as you can get. And then we're going to go on our y-axis to negative 4. That's our y-intercept. And then, do your best to connect them. I didn't do the greatest getting that line in there, but I don't think we can. Oh, there we go. We can if you tap it. If you turn on the texting, the T up at the top, or not the text box thing, and then you tap on it, you get control over the top of the line too. There you go. I've never been great at making it exactly where I want it, so if you have control over it, that's good. It's not a big deal. Putting the arrows on there does indicate that it's going to stretch out to infinitely up and down. It does kind of, show, and stretching that out is always a good idea. Okay, let's talk about the distance formula real quick. Back in Algebra 1, probably, then you probably did it again in geometry, maybe even pre-algebra, you might have used the distance formula. Let's talk about where it comes from, what it is. The distance formula is derived by the Pythagorean theorem. You'll notice it's the square root of the difference of the x's plus squared plus the difference of the y's squared. So it really just derives itself from that quadratic formula. It is connecting it, making kind of a right triangle every single time. You're going to label one of your endpoints of your line segment x1, y1, and the other one x2, y2. And then if you were to connect them, that is always going to be the distance between them. Because we are squaring it here, be very careful of your order of operations. You are squaring those things and adding them together and then doing the square root of that answer. So your square root is really the last piece of the puzzle that you want to do. So if this first example, we'll call this 5A. In example 5A, if they want us to find the distance between those points, it doesn't matter which you start with. Some people will start from left to right, but it doesn't really matter. Just label and be consistent. So let's call this one x1, y1. And let's call this one x2, y2. Now let's analyze the formula. This is there's a few different places that people tend to make mistakes. We are subtracting x1 to subtract in algebra. Just remember to write down the opposite. So if it starts out to be negative, you want the opposite of x1. You want the opposite of x2. So you are subtracting, so remember that sign is going to give you the opposite there. Once you square each individual thing, put that together before you square root. So remember, square root is it's the square root of the final answer. Okay, so let's do this. So our distance is going to be the square root of. Now, we're going to start out with x2, which is 2. We're going to subtract x1, but when we're subtracting that negative, just write the opposite down. And then we're going to square it. And then we're going to add on the difference of the y's. So it's going to be y2, 3. Minus negative 1, just write down the opposite. And now square each one before we add it together. We ignore the square root until the very last step. 2 plus 3 is 5, so that's going to be 5 squared. 3 plus 1 is 4, so that's going to be 4 squared. 5 squared is 25. 4 squared is 16. So that is going to be the square root of 41. Now, my suggestion is, I want that is the correct answer. You know, we're done. But always just make sure that you can't reduce it. I don't want a decimal. Unless they say, give me the distance to the nearest tenth. That tells you, hey, I should plug that into a calculator. I like the square root of 41. It's the exact answer. If you needed somehow, like if it was an application where you wanted that decimal, then throw it into a calculator. But don't waste your time with the calculator for most of it. Let's try to do as much as we can without one. If there was a perfect square hiding in there, now remember, it's very limited to what numbers that we're talking about here. 4, 9, 16, 25, 36. If that goes into 41, make sure you reduce it. But otherwise, we're done. Let's try one more. Let's call this 5B. Again, label your points. Really doesn't matter which one you do. Let's do x1, y1, x2, y2. Let's practice plugging it into the formula. So the formula is up there at the top of the screen. So it's going to be the x2.11 minus 1 squared plus 9 minus 4 squared when we plug those in. Now, again, I want to talk about what steps you have to show me. At least show me that much. If you do a lot of the rest on a calculator in your head, so be it. But if you show me that, then I know that you're correctly using the formula. Okay? So you decide what amount of steps you want to show me. But I want to show you, a nice amount of steps just so that you can understand where everything comes from. So 11 minus 1 is 10. That's a positive. You don't really need those parentheses when you're having a positive there, but if you want to put them there. And then 9 minus 4 is 5 squared. You can maybe even do this part in your head, like I'm talking about some of the stuff. Feel free to do in your head. 10 squared is 100. 5 squared is 25, so that's the square root of 125. Now that is the correct answer. But what's a perfect square that goes into 125?
25.
25. So technically, mathematically, it's more precise to remove that. So if we think about the fact that that is 5 times 25 and that 25 is a perfect square, we can square root the 25. That 5 comes out and sits in the front. But there was a 5 under there that we could do nothing with, and so there ends up being a 5 underneath. So I prefer for your final answer this. Is this correct? Yes. Is this better mathematically? especially as we're trying to head toward calculus? Yes. So give me this. If you get this, let's say that point, the problem is worth 4 points. You might get 3 out of 4 if you stop here. And this is the final best version. Okay. So there is an example of the distance formula. Pretty good, right? Another formula we see relating to points is the midpoint formula. In calculus, we do come across the midpoint formula or versions of it that give us certain information, so it's important that we know that. Just like the distance formula, we see an x1 and a x2 and a y1 and a y2. This time, these basically are the average of the x's, and these are the average of the y's. So it's an average formula. What do we do when we average two things? We add them and divide by 2. Think about halfway between x1 and x2 is the average point, the middle point. So that's where the midpoint formula comes from. It is just an average. Let's call this 7a, and let's do this first one here using our midpoint formula. So if we had a line segment connecting these 2 points and we wanted the point directly in between the point 7, -2, and 9, 5. That does say 9, 5. It's the halfway point. So you're going to average the x's, average the y's. That's your point. So let's label them x1, y1, and x2, y2. Use a capital M for midpoint. It's just kind of a given that we use a capital M for that. Get used to using whatever notation they did. That's another thing that will help you as we head toward calculus. Now let's plug into the formula. If we average the x's, that's just going to be 7 plus 9 divided by 2. If we average the y's, that's going to be -2 plus 5 divided by 2. So if we think of the midpoint as the average of the x's and the average of the y's, that's the way to remember the formula. If it is divisible by 2, great. 7 plus 9 is 16. 16 divided by 2 is 8. You have to add them before you divide. Order of operations tells us we add or subtract, or we multiply. There's grouping symbols, I'm sorry. So please excuse my dear Aunt Sally. The first thing is a parenthesis or a grouping symbol. Although you don't see it, technically that fraction bar separates them and says we have to add the 7 and the 9 before we can divide by 2. So if we do the next one, -2 plus 5, that's 3 over 2. Since that can't divide, leaving it 3 over 2 is perfectly fine by me. Graphing-wise, 1.5 is helpful. If it's a decimal that quits and you want to see that decimal, go for it. But I like that. It's precise. I know exactly what it is. So you can just leave it. Okay. Let's do another one. We'll call this 7b.
I have a quick question about
Yes.
part A.
Uh-huh.
Maybe I'm being dumb here and missing something.
No, you're good.
But for like 7 plus 9 over 2, wouldn't you divide that by 2 and it'd give 4? 8 divided by 2?
Oh, I did it. You would do 7 plus 9.
Right.
That's 16. And then you divide 16 by 2. You did it
Yeah.
twice. Yeah.
Okay, never mind.
No, you're good. Okay, so let's do 7b. We're going to label them x1, y1, and x2, y2. We're going to average up those x's, so -2 plus -8 over 2. And then we're going to average up the y's, -1 plus 6 over 2. -2 plus -8 is -10. Divide that by 2, get -5. -1 plus 6 is 5. Divide that by 2, we can't. So just leave it 5 over 2. Since divided by 2 is always going to give you a 0.5 for whole numbers or integers, if you want to make that 2.5, so be it. If not, again, that's a perfect answer. Just leave it. So there is the midpoint. So that gets us to 2.1. Now, we have a good chunk of class still left. So here's where what we're going to do is we're going to start a little bit of them together. This looks like a lot of problems, but it's actually not. I've given you the odds because the odds are in the back of the book. I want you to use the back of the book. But what I want you to do is just check them as you go. So that maybe tomorrow when we go to work on the next section of notes, you can answer, I can answer any questions you have about what you've started. So remember, this technically is a college level math class. So you need to act like you're taking that responsibility and doing some things and then coming back to me with some good questions, okay? So that being said, so if now what we're going to do is we're going to open up the book. Now, there's a chance because again, this is the first year we're using this book. So even though it says we're going to do odds 5 to 41 and then all of 43 to 47, sometimes when I go and look, I go, oh, let's not do that problem. Let's not do that problem. So, you know, okay. So now if we could open up the book together. The book, remember, it looks like that red version you see right here. It says algebra, trigonometry, and trigonometry. This is our book. Let me kind of give you some hints about what is helpful in the book. So, so we're skipping to chapter 2. So what you might want to do is over here on the side, open up the pages so you can see it. We're going to skip, I can give you some ideas. Okay, so you can see there's chapter 1. See where they had that picture on? And I put that picture of what chapter 2 looks like on the, so scroll until you see that little picture we saw at the beginning of the notes. We're getting there. I think we're getting close, unless I missed it. Trying to tell you what page it's on. Oh, thank you. You guys got there ahead of me. I was afraid to scroll too fast. Okay, so that looks like the beginning of the chapter, and I tend to do a lot of their examples because the homework is going to look like that too. So if we scroll then to 2.1, the problems start on page 84. It's 102 in the PDF, but page 84 in the top corner, okay? So what I would hit now is please hit that little bookmark. So it's going to be a heck of a lot easier to find that page. So every time we have an assignment, let's bookmark it, okay? Okay, so now I would suggest highlighting. You take your highlighter and let's highlight 5 to 41, and let me see if we're really going to do those. Okay, so that says to find the x and y intercepts. Solve for y. Those are quick things. For each of the following, find the distance. Distance is a quick thing. Then there's midpoint. Okay, so up to there, I know we're going to do up to 25. Now let's look at the other things. That's an easy thing. That's good to think about. That's quick. Like I did. Those are good things. Let's see which is one. Those are good. That's, we won't do that one third. Okay, so that's good. Those are good to do. So we're really up to 37 so far. Well, I'm going to find that and plot the x and y intercepts and graph the line. Okay, so that's a good thing to do. So yeah, we're going to do up to 41. We're going to do a few together here in a second. Okay, so then jumping to 43 to 47. Okay, we're probably going to do that right now. Okay, so again, we have some time here to at least get started. So we're going to do a few of these together right now. Okay, so yeah. Oh yeah, I'm sorry. Which ones did you want to see? Oh, okay, at the top? Okay. So let's get started and let's just do a few of each together. We'll do one from this one and one, kind of do one example of each to get ourselves started. Some people like to, at this point, underneath the page we've bookmarked, I've seen students that will add a blank page so then they have a little more control and have more room. That's a good thing to do. Some people, add in their graph paper or just make the whole thing a piece of graph paper. Whatever you want to do is fine by me. So remember, it was, let me write it up here, it was odds 5 to 41 and then 43 to 47 all. Odds 5 to 41 and 43 to 47 all. Remember, that's right in your note sheet. You can always go back to it. And I'll probably type that into the instructions. Okay, so let's go ahead and start with number 5. And let's talk about what you're going to do for 5, 7, and 9. For those ones, it says to find the x and y intercept without graphing and write the coordinates. Well, all you need from me is that 0, 0 chart. And so for number 5, all I want to do is I want to plug in 0 for my y to find my x-intercept, 0 for my x to find my y-intercept. So we're just going to do that algebra. So let's do it down here so we have some room. So, so if we find our, let's start with our x-intercept. If we plug in 0 for the y, that's the one that's a slight bit more complicated. So we get 0 equals negative 3x plus 6. We're going to be able to move the 6 to the other side. Divide by negative. 2 negatives make a positive, so that answer is positive 2. So you can even write on the side that is our x-intercept. So the x-intercept, you're always going to make the y equal 0, and then you're going to solve. That is usually, algebraically, slightly more complicated. Okay, now let's go ahead and find our y-intercept. This time we're going to let x equal 0. That mathematically is usually a touch easier. So that's just negative 3 times 0 plus 6, or 6. Now they said to write the coordinates. Our table provides that. If you want to actually write it so it looks like a point, feel free to, but you don't have to. The table gives us everything we need. So that's how you would do that first section, 5, 7, and 9. Okay, the next section, let's do one of those. It says for each of the following exercises, solve the equation for y in terms of x. So that just means we wanted to say y equals all the other junk. And so let's do number 11 together. So in number 11, we need to solve for this y here. So just use your techniques of moving around stuff in an equation. Just follow order of operations as you go. I'm going to first subtract 4x from both sides. So I just tack it, especially for a subtraction. I tend to tack it on the end. You could have also written 2y equals negative 4x plus 8. Either of those are acceptable. You decide the way you want to write it. It doesn't matter to me. They're both correct. And then the last thing is we have to divide everything by 2. So make sure you put everything with a division by 2 underneath it. And so we get y equals 4 minus 2x. If we did the same thing over here, another correct version of the answer is y equals negative 2x plus 4. Either one is perfectly correct. You can write it like this. You can write it like this. I don't care. They're both correct. You decide which way you like it. Some people like writing it like this because it has that feel of that y equals mx plus b kind of look to it, but it doesn't matter. They both get you the same place. Do one, pick one method and do it, okay? So that's what they mean for that section. Now let's jump to find the distance between 2 points. For 17 through 19, or 17 and 19, they want you to use the formula and then reduce down the radicals as far as you can go. Let's do 21 together. They want us to use a calculator and round our answer to the nearest hundredth. So let's do that one together. So for the distance formula, we're going to label our points x1, y1, and x2, y2. Remember what the distance formula is. It's the difference of the x's squared plus the difference of the y squared, all under a square root. And so the difference of the x is going to be 41 minus 19 squared. That's going to be our x's. Now we have to do y2 minus y1. So that's going to be 71 minus 12 squared. Do those subtractions next. You always do what's in the parentheses first. So that's going to be 22 squared. 71 minus 12 comes next. That's 59 squared. Now you have to square them and add them together before you're allowed to do the square root. You can't touch the square root until the very end. And so that's going to be 484 plus 3481. And it is the square root of that answer. If you try to do the square root of the pieces, you are going to get an incorrect thing. So it is the square root of 3,965. Now, here they wanted us to use a calculator. If they wanted us to break it down, we would just start trying to see if there are any primes in there. But they just want us to throw it into a calculator. Remember, in a calculator like this, the square root is found above the square button. You would just hit second first before you do it. There is a calculator in self-service. If you just type CALC for calculator, you should be able to find a free calculator if you want it. Desmos has a calculator in it. There's lots of versions. The square root of 3,965 to the nearest hundredth would be 2 decimal places. It is approximately 62.97. 62.97. So just round to whatever decimal place they ask for. If you give me a decimal place and it hasn't said anything, usually a tenth is fine also. If they specify, use what they have specified. So that is that section. We don't have too much more time right now, but let's find ones that are weird. Let's see, midpoint is usually good. Let's talk about this little section right here as much as we can until the bell rings. It says find the distance between the 2 endpoints. It says find the midpoint between the 2 endpoints. So the first thing I will suggest for this is to actually write down the points. So this is the point 5, 2, and then this is the point -3, 4. So write those points down. That will be helpful. And then I'll take any questions you have at the beginning of class tomorrow. So give this a shot and start trying to work on this today.